Eureka, 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 Eureka!
I got it!
Welcome to Eureka Publication Private Limited, creators of engaging textbooks and digital learning tools. Let's dive right in.
In this video, we will calculate the acceleration due to gravity through a simple experiment. We drop stones from known heights and measure the time they take to reach the ground, making sure to release them without any initial push, so the initial velocity is 0. Then we use the equation h equals 1/2 at squared to compute acceleration for each trial and take the average. We will also compute the final speed using v equals the square root of 2ah. Finally, we will highlight the key insight that this acceleration is independent of mass, as long as air resistance is negligible. Here is our setup: a tall building, a few floors, and the ground. We will drop a stone from different floors corresponding to different heights. We carefully release the stone without any initial force, so u equals 0. We measure the time of fall using a stopwatch or timer, and use those times to compute the acceleration. Trial 1. Height h1 equals 5 meters. We release the stone with 0 initial speed. The measured time is about 1.01 seconds. Using it equals 2h over t squared, the computed acceleration is about 9.8 meters per second squared. Trial 2. Height h2 equals 10 meters. The measured time is about 1.43 seconds. Again, at equals 2h over t squared gives about 9.8 meters per second squared. Trial 3. Height h3 equals 20 meters. The measured time is about 2.02 seconds. Computing at equals 2h over t squared, we again get about 9.8 meters per second squared. Taking the average of these accelerations gives approximately 9.8 meters per second squared. This is the acceleration due to gravity, usually called g. It is the constant acceleration of any object in free fall near the surface of the Earth, so long as air resistance is negligible. We can also compute the final speed just before impact using v equals the square root of 2ah. For example, from 20 meters with it equals 9.8, v equals the square root of 2 times 9.8 times 20, which is about 19.8 meters per second. Here is the key insight: the acceleration g is independent of mass. To visualize this, imagine dropping a heavy object and a light object from the same height and ignoring air resistance. They fall with the same acceleration and reach the ground together. This is a fundamental idea in physics. Summary: we dropped stones from known heights, measured time, used h equals 1/2 at squared to compute at equals 2h over t squared, and averaged to estimate g near 9.8 meters per second squared. We also computed final speed using v equals the square root of 2ah. And importantly, g is the same for all masses when air resistance is negligible.
This session was brought to you by Eureka Publication Private Limited. Think it, dream it, do it. Join us for the next lesson. Till then, like, subscribe, and share. Eureka Digital Publications, creators of trusted textbooks and digital learning tools.